Hello everyone, my name is Ava Chavez-Houwer, and today I'll be presenting the following three parks: the Wind Cave National Park, the Badlands National Park, and the Theodore Roosevelt National Park. The Wind Cave National Park began forming over 350 million years ago, and the Badlands National Park landscape formed about 75 million years ago. By the late 1600s, the Lakota tribe migrated west due to the fur trade conflicts. By eventually settling near these parks, the Badlands was vital for hunting buffalo, bison, and elk, gathering plants, and practicing cultural and spiritual traditions, while the wind caves were used as a sacred site. The Wind Cave National Park was established on January 9, 1903 by President Theodore Roosevelt. It covers 33,847 acres in the southwestern Black Hills of South Dakota. The Wind Cave was the sixth national U.S. park and one of the first caves globally designated as a national park. The 2005 Boundary Revision Act expanded the park to better protect its landscape. In 1889, early exploration began when Alvin McDonald mapped 8 to 10 miles of the passages by candlelight, naming many rooms and corridors still known today. Around 350 million years ago, during the Paleozoic era, the Wind Cave National Park Foundation formed under a shallow sea. As the water evaporated, minerals were left behind, and in the early Mesozoic era, the cave began forming. Layers of gypsum and other minerals became the Madison limestone, which makes up much of the cave today. Extending over 167 miles, the Wind Cave is one of the oldest and most complex caves in the world. The Wind Cave National Park features Precambrian rocks like granite, gneiss, schist, and pegamite, along with limestone, gypsum, shale, and sandstone formations. The park's landscape was shaped by the Laramide orogeny, which formed when the Farallone Plate subducted at the shallow angle beneath North America, pushing mountains and basins far inland and creating much of the modern Rocky Mountains. As for climate and fossils, the Wind Cave National Park has a warmer, drier climate than the northern Black Hills, with 30 inches of snow annually, warm southern summers, and cooler evenings. June and July often bring severe storms, and climate change has raised through drought and wildfire risks. The park also preserves fossils of mollusks, early mammals, and I'm not sure how to pronounce that, subhydrocodon and Mesohippus, as well as turtles and small deer. As for the Badlands National Park, it is located in the southwest of South Dakota. And it spans 244,000 acres. It was a designated national monument in 1939 and became a national park in 1978. The Lakota tribe named it Makosika, or other known as Badlands, due to its harsh terrain and scarcity for water. The Lakota pushed west during the fur trade and mainly used the area for seasonal hunting. As for the Badlands, they began forming about 75 million years ago, but erosion over the past 500,000 years carved its dramatic canyons. The Cheyenne and White Rivers shaped the soft rock. The park erodes at roughly 1 inch every 10,000 years. Geologists predicted that the canyon formations could disappear in about 500,000 years. The Badlands National Park contains layers of sedimentary rocks such as shale, mudstone, siltstone, sandstone, and limestone. The national park is a part of the same orogeny of the Wind Cave National Park, which is the Laramide orogeny. It has convergent tectonic boundaries and was geologically formed with prairie grasses. As for the climate and fossils, the Badlands National Park has extreme weather from 116-degree summers to -40 winters. Summers are hot with occasional severe storms, and winters bring 12 to 24 inches of snow. The park gets about 16 inches of rain, with June being the wettest month. The fossils that can be found in this national park include Brontotheras, Oreodonts, and Mosasaurs. The Theodore Roosevelt Park is located in North Dakota. It was established on April 25th, 1947, after President Theodore Roosevelt's death. The national park is 70,477 acres, which is approximately 110 square miles. The national park is 76 years old. The park's formations began 65 million years ago during the Paleozoic Paleocene epoch. Rainfall and Ice Age glaciers reshaped the land, redirecting rivers southward towards the Mississippi. Erosion of the national park is due to the weathering rainfall in the Rocky Mountains. The Little Missouri River followed the steeper path, carving deeply into the land and creating the landscape we see today. As for the climate and fossils, the Theodore Roosevelt National Park faces climate change impacts, including warmer nights and more rainfall. Summers can reach between 70s and 80s, and winter drops to single digits. The park gets about 15 inches of rain and 30 inches of snow annually. It has intense summer storms, and occasionally winter blizzards occur. The fossils that can be found in this park include Champsosaurus, petrified wood turtles, and snails. The Theodore Roosevelt is filled with sedimentary rocks. The type of sedimentary rocks that the park has is siltstone, mudstone, sandstone, bentonite clay. The park is a part of the Laramide orogeny and is located in the North American Plate in the Missouri Plateau. In conclusion, when researching these three national parks, it showed me how their geology, wildlife, and conservation are connected. Learning their history gave me a deeper appreciation for their beauty and the importance of protecting them for the future. And here's my bibliography. Thank you so much for listening.